So this is a workflow video for BMDExpress 2.2. It's a quick overview of how to work through the analysis pipeline. And there are a couple of steps involved in analyzing data in BMDExpress. Number one, you will need to update the annotations when you first open the application. You can do that here, File, Update, Annotations. And what it will do, it'll populate, goes off to a server at a company called Siome, and will come back and identify, give it with a list of platforms. These platforms range from Affymetrix platforms, Agilent, BioSpider. We also have Ensemble and RefSeq IDs for a number of species, and the species are listed here, where you can download. So if you're using Ensemble or RefSeq IDs for your RNA-seq or things along those lines, it will recognize it. Also included in this download are up-to-date GoTerm annotations and Reactome pathway annotations. And so you'll select your platform and hit update, and then it'll download, and at which point you'll be ready to upload your data. So I am going to show you real quick here what your data has to look like in order to get into BMDExpress. So on the first row is your sample ID. This could be your well or your animal ID. You can see this is a reasonably large experiment. Next is the dose level that you applied to that animal or sample or well. And after that, starts your features that you measured. These are your probes. In this case, this happens to be the S1500 platform from BioSpider, but these could be Affymetrix probe IDs. And then in the matrix is normalized data. We do not normalize data in BMDExpress, so you will need to normalize your data before you load it into BMDExpress. So I'll quickly show a loading of a file now. So now that you have your file, it'll be a tab-delimited text file that you'll save it as. You go in here and you'll go to File, and then you'll go Import Expression Data, and you'll grab an expression data file, and I'll simply hit Open. And first thing it'll ask you is, and ideally you'll have downloaded the platform annotations. It will recognize the platform because it looks at the probes or the features that are measured. And if it's not the correct one, you can drop down and select the right one. You hit OK. And then it asks you to choose what the transformation was. Is it log2? Is it natural log? And you have a number of options. Or if you don't have it transformed, oftentimes it's common practice to log2 transform your gene expression data before analyzing it. And this is also goes into obviously calculating the fold change value. So if it doesn't know that your data is log value, the calculations will be off for fold change. So when you simply hit OK, and what will happen is it'll load here, and I had already loaded this same file here, so it gave it a sub number. So we can just remove this for now. Okay. Now you can multi-select when loading files, so I actually loaded all three of these files together. So when you do the import, you can just shift-click on as many files as you need, and load them all at once. It'll iterate going through the actual loading process, so you'll have to go through, is this log2, and then or what platform is it, and is this log2? So you can actually load multiple platforms at the same time, and if you have different log values and things like that, you can load those also. But it'll just iteratively walk through each one of the files you load. The next thing you'll do after you've loaded your data is if you want to look at your data, you can click here. So right now we are in the expression data domain. I should point that out. We have actual now data domains here. In the expression data domain, there are 3 pre-filtered domains. These are when you run a statistic on your data and you have features that have passed the statistic. Then you have benchmark dose analysis results and functional classifications. We've just loaded data, so it's just in the expression data file. And when you load this, you'll see details on the file. Right. So again, in order to get to load, you select the box there. you'll in the expression data section for the visualizations, there are principal component analyses, and then there's the actual data. So if you wanted to then go to the next level, right, which is now I want to run a filter my gene expression data for features that are responding to say chemical treatment. Then what you can do is you can either select a single one, and again, for analysis you select the actual file name here. You don't select the radio button. The radio button is simply for the visualization and showing the data here. But if you want to set it up for a subsequent analysis, you select the files here, and then you go to Tools. And in this case, we can run a pre-filter. I've run all these already, so we're not going to run them, but I will show you them. There's 3 pre-filters that we've built into BMDExpress. There's the Williams trend test, which is simply a parametric trend test, and you can all information on all of these settings is available in the documentation. We have both a statistical tests and an effect size or fold change filter that you can apply. One of the things you will notice is if you decide you want to change the settings, you can save those settings, and the next time it'll come up with the settings you saved. So I am not going to do that now, and I'm not going to run this, but you'd simply hit start, and it would go through and run the analysis and return the results under the Williams trend test subfolder, which would be here. So you'll see that. So, but let's just go through. There's the other pre-filters. There is a one-way ANOVA, which is the original one-way ANOVA. So again, I'm in the expression data domain here. I've selected all 3 files, and I'm going to pre-filter one-way ANOVA. And again, the settings are very similar to the Williams trend test with the statistic and the fold change. And then there's a non-parametric trend test called Origin. And again, the parameters, description of all the parameter settings, and then of course our fold change cutoff is captured in the documentation. So if you have questions about what each one of these represents, it'll be in the documentation. So if I have already run the Williams trend test, and that's the data that I'm going to use, so I'm going to go to the Williams trend test. So imagine I have run this data, I run the Williams trend test, I go down here now and I select Williams trend test, and here are my results. And I get very informative file names. This is data 1, Williams trend test, p less than 0.05 was used, there was no multiple testing correction applied, and there was a fold change filter. So if I want to see the data, you simply select a file. And one of the things about the pre-filter section, whether it be Williams one-way ANOVA results or the Origin, is you have the possibility of actually loading more than one data file. So I've just loaded one right here at this point, and there's a number of different visualizations. These are your typical volcano plots. But there's others here, histograms and things along those lines to show you your data. To visualize your data, there is the results table. You'll notice that this is different than the expression data file that was loaded. These are the actual results. These are only the probes that pass the statistical filter or the Williams trend test combined with the fold change filter. And what you have is adjusted p-value, unadjusted p-value, adjusted p-value, max fold change absolute, and then the fold change at each dose level. And you'll find these same things in each of the 3 pre-filter sections. This is the basic format. Over here we have a filtering system. So if you wanted to add a filter, so we can say, okay, let's add this filter, and it has to be, so in this case it's the max fold change unsigned, so basically it's the absolute value. So we want everything that's greater than or equal to 2, and what you'll notice is it automatically updates. The image updates, and now you can see here the max fold change goes down as far as 2. And again, you can sort all these columns and things like that. There's other functionality in here that I'm not going to cover right now, and I'll cover in other sections, but there's different ways of labeling. You can shift click and label certain nodes. You can you can do a number of different things with the visuals, but we'll touch on the visuals later. I want to work through the analysis right now. So now I have my Williams trend test result. Now I've got my features that are responsive to chemical treatment in this case. So what I'm going to do now, in order to now, I'm going to fit these the results of these analyses to curves. So I'm going to take the probes that are responding and I'm going to fit to multiple what's called parametric models. These are BMD models derived from the EPA's BMDS software. And so I've selected these files to be analyzed. And I go to Tools, and then I go to Benchmark Dose Analysis. And you'll see here, because I've multi-selected, this is multiple data sets. So it basically allows you to run things sort of in batch. And so we have the models you can pick from. And you can pick as few or as many as you want. Parameters, and these parameters are all explained in the documentation. How the model selections take place, so it's going to compare the exponential model, say, to the poly models to the power model, and say which model best describes the data, and we'll then use that model to identify a potency value for that gene. And then over here, if you have the greater number of threads you have, the more quickly your data will be analyzed. And then finally, there's the Save Settings button and the Start button. Save Settings. So if you don't like the default settings, you can set them yourself, and then you can hit Save Settings. And next time you load data, it'll show you the Save Settings will populate, and you'll just simply hit Start. So I've already done this, so I'm just going to go to the next section. So once you do this, what will happen is there will be BMD files that populate in the next section down, which is, well, so these are the pre-filter sections here. The next section down, or analysis section, would be the BMD benchmark dose analysis. And so here is the 3 benchmark dose analyses, and you can tell it's a BMD file by the fact that it says BMD. And so what you can do here, in order to see the analysis, you select the button here, and it gives you a number of different visuals that break down the results of the BMD analysis. And then you get all the details over here of how the analysis took place. And again, over here, all the filters. So if you want to apply filters to anything in the columns here, we typically, so we have to have a BMDL between 40, and we also want a best fit p-value greater than or equal to 0.1. And you'll see how the data changes as you begin to filter it. So again, a number of different visuals that you can look at. We have accumulation charts in this section. This is basically a BMD value. So it ranks the BMDs from highest to lowest. The one with the lowest value is given the rank of 1, and then going up from there, increasing rank. And so this is sort of the accumulation of the rank. So lowest BMDs over here, highest BMDs over here, and this is how they accumulate as a function of what the BMD is. But yeah, so there's a whole bunch of these sorts of charts. And one of the nice features here that I will just highlight real quickly is we have a mark your data function. And so as you recall from the update, what we pull down is go terms and reactome annotations for all the genes. And so what you can do is you can say, okay, show me the genes in this case, I went to mark my data. I can do xenobiotic catabolism, and there's a couple of genes there. And so you can actually type in the names of your genes too. If you have gene names, you can just put them in there. It doesn't matter if it's a specific Go term or not. So if you have your favorite suite of biomarker genes, you can just load those. And what'll happen is then they'll show up here, and they'll show you what the fold change value is and what directionality. If it's blue, it's down-regulated. If it's yellow, it's up-regulated. And these are all movable. You can move these around. So this actually carries through the rest of the charts too, where there's individual dots, and I don't think that actually there's any more diagrams that have those. But so yes, so you'll see more of this sort of stuff, these interactive plots, as you get down into the functional classifications, which is the next step. So what you've done here is you actually, I'll note here that you have identified BMD values. So this basically gives you the specifications of all the fits for each one of the probes. You can actually take the data here and completely recapitulate. If you have the model formula, recapitulate the dose response curve, at least the model dose response curve. And it also tells you in this table what the best model was, best fit model, what the BMD on that model was, the BMDL, various things along those lines. And you can actually, if you want to, you can just export this data file. There's a number of other metrics that we've incorporated into this. We've brought down the max fold change value. So if you want to know the BMD of the gene with the maximum fold change, you simply sort the column. And it happens to be this one here, which is 12-fold. It is BTG2, and it has a BMD here of 16. So, and then it also brings you down all the dose levels. Fold change, it's different dose levels. So you can evaluate the data at the BMD analysis level. But really where the power of this comes in is not necessarily in the fact that it would look at these individual genes. While that is, of course, very powerful, the next step in the analysis is to take these genes with their associated BMDs and then parse them into Go terms or pathways or your own favorite set, a collection of gene sets, right? We like to use the Hallmark gene sets from the Broad Institute sometimes, so you can use those also. So I'm going to show you real quick the setup for doing the analysis of Go terms on these 3 BMD files. So remember, we're in the BMD benchmark dose analysis section. I've selected these, shift-clicked it, and selected these 3 files. I then go to Tools, and I go to Gene Ontology Analysis, and that's going to do is going to parse the genes in this table into gene ontologies. And you can use either the universal set of Go terms or the different subsets. You have the option of, all these options here are described in the documentation. We typically use a remove BMD with p-value less than 0.1 here. That's an EPA recommendation, and then a BMDU to BMDL ratio to help remove highly uncertain estimates of BMD. And then we also have recently just incorporated this limited gene set redundancy. Oftentimes with large gene sets like Go terms, you'll have, when you eventually populate the categories, there'll be multiple Go terms with the same set of, say, 3 or 5 genes, and so they end up with the same BMD value. So we have this mechanism now. We'll describe in the documentation on how to eliminate systematically some of that redundancy. You have the Save Settings button here, as you do in the other sections, and you can simply hit Start to run it. And what will happen, as with the reactome analysis too, so before I jump to the next section, I'll show you the other. You can do signaling pathway analysis, and it's just simply reactome. It's just like the Go term. Setup is virtually identical, with the exception of you select the pathway set. The other thing that you can do for functional classification when you're in the BMD analysis section is you can do what's called a defined category analysis. So a defined category analysis is a analysis of your own gene sets, and there are 2 files that you need. You need a probe file that maps the probe to say a gene symbol, and then the category file which maps a gene symbol to a pathway or a gene set or whatever it happens to be your favorite file. So I'll quickly show you what those look like. So we will go to the S1500. So we're using the S1500. So we have a probe file here, human S1500 probed entree gene, and I'll open that. And what you can see here is you have the probe name from the S1500, and you have the category component, which is the entree gene ID. And you simply hit Use. Yes, it has column headers, and you hit OK. And because I used the same name in the file as was designated here in the software, it automatically recognizes it. Next, I will load the Hallmark gene set file, defined category file, and I'll just simply use, because this is a pathway file, it's platform agnostic. I will use the human 133. And what you'll see here, there are three columns of data. There's an ID, there's a name, and then there's the entree gene ID. And we want to use the headers. And you notice, considering I didn't have the exact names matching, now I need to pick them. And then I'll just pick those 3 columns and how they match up. So the component is the entree gene ID, and the name is the MSigDB name. And once you've set that up, you've now mapped your probes to entree gene IDs and your entree gene IDs to pathways. And you simply hit Start, and at which point it will populate in the functional classification section. So let's quickly go to the functional classification section, which is here. So I've run a bunch of functional classifications already, and what you'll see here are very long names describing the files I ran. So example data 1 through 3, I did go all, and what you'll see here, it tells you, what the parameters were for running the go analysis. We had a p-value greater than 0.1 and a ratio, a BMDU to BMDL ratio of 40. And you'll notice I deduplicated this set here, so that's also showing up. That's one of the selections for the setup for the functional classification analysis. And then I've also run the hallmark gene sets. This is the hallmark MSigDB version 5 with deduplication. And so what we can do now is we have run all these analyses, is you can load them here. So I'll load one of them here. And then what we can do is, we're not going to use the Fisher exact test. We're going to say genes that pass all filters. So the filters are like the BMDU to BMDL ratio that fit p-value greater than 0.1. And we're going to say it has to be at least 3 genes in a category for us to see it in the visuals. And the percentage populated for any given gene category, and this is a gene, in this case it's one of these Go terms, has to be at least 5%. So it has to be at least 5% populated based upon the annotation. And as you'll notice, it actually shifted around the dose response, or the accumulation chart here, and it also altered obviously the population of the various other charts. And I should say that there are a very large number of charts here for visualizing the results from the functional classification. What's nice is if you want to see your data, you can now load all the Go term analysis for all 3 of these example data files. It'll take a second here, and voila, here it is. There are the 3 accumulation curves for the example data. And so you can see the red one, I guess, is a little bit more potent. As you see, it has a lower BMD here. One of the other things you can do is you can mark your data. So this is one of the more powerful things that we recently incorporated. So you can do xenobiotic catabolic process, and then we can do xenobiotic metabolic process, and let's see what else. Glutathione catabolic process. Let's see if they show up here. And there they are right there. Only xenobiotic metabolic process shows up. But if the other ones were on here, they would show up. And they also populate over here too, as you can see. And you can look at a number of different plots here. We have range plots that show you the individual Go terms and their ranges. We have bubble charts, which plot the negative log of the Fisher's exact two-tail test. That's an enrichment test against the BMD median. All the accumulation charts for all the different metrics for each one of the BMD value, different BMD calculations, mean, median. And so there's a whole bunch of them here. And if you are not inclined to our visuals, you can create your own by simply going here and saying I want a bubble chart, and I want the x-axis to be, pick whatever column you want. We'll say BMDU median, sure, and just use absolute value. And then we'll compare that to the BMDL median, say absolute value, and then we want the Fisher's exact test. You go down here, and then you'll say negative log, and it will, there it goes. So there is your comparison of the absolute value of BMDU median versus absolute value of BMDL median, bubble size being the negative log of the Fisher's exact two-tail. And you can load this up, and if you want to, you can export the data from creation of this plot. You can modify the axes if you'd like. You can shift things around here. So any number of things. One of the things we didn't note here on the filters is you can save the filter so it'll pop up again, just like in other places. And so one of the other things is you can also shift click and export, or alternatively delete these items if you don't want them. You can, and this is true in all these sections here, you can check all or you can clear all. And so I'll give it a second to reload here, and my saved, yep, see, there's my saved filter. It came back up again. So there's a tremendous number of functions in here, and great visuals. And again, it goes from taking your normalized expression data in the right format after you, and of course you have to update the annotations, through a pre-filter, which lately we've been using a Williams trend test, but you could use an ANOVA or the Oriagene non-parametric trend test if you're so inclined. We then fit the features that come through, or the genes, if you would, that come through the pre-filter through to multiple dose response curves. These are parametric dose response curves that come from the EPA BMDS software. We then partition those genes with adequate fits into gene sets, and then determine a number of different values for estimating the potency of that gene set. And that's one thing I didn't touch on here. We've typically used BMD median as our metric for a pathway sensitivity, so the most sensitive pathway. In this case, for example, data 1 is the regulation of spindle checkpoint. And what you'll notice here is one thing I didn't highlight here is if you only have one of these files selected here, you don't have the analysis column here. But as soon as you select more than one, the analysis column will show up. The other thing that we've tried to do to enhance some of the analysis is we've actually incorporated a number of different metrics for gene set characterization. So we have an overall direction now, which is, are the probes generally moving up or moving down, proportional in a disproportionate manner. Tells you what the percentage up or down is. It also gives you the max fold change in a group, and so you can see whatever this is has 185 fold change, and that's positive regulation of lipid catabolism. You also have min fold change, total fold change, so you just add up all the fold change value, and then mean fold change. And mean fold change is looks like oxoreductase. One of the things that you'll notice here as a reason why we introduced the deduplication is the genes that made it through the analysis that ended up populating these 4 or 5 categories here are all the same. And so what you end up doing is reporting the same BMD median, because they're all the same genes that all have the same BMD value, so the BMD median value is going to be the same. And so if you go to the deduplication, you wouldn't see that. These are all from example data 2, it looks like. So you would only see one of these. It would be the one that's most has the highest percentage population, and then the highest number go term. So these two are tied here, and then this go term would put out. So what we'd end up reporting out of these here is caffeine oxidase activity. So that's a quick overview of BMDExpress and how to get you going.